Hello, this is Math 2134 coming to you from the College of DuPage for fall of 2020, and this is the conclusion of the lecture entitled Lines and Such. So this was the problem you were working on. If you finished it, great. If not, I'll give you time to do it again. You know what to do. Let's see how you did. So we have 2 points, and we have the equation for slope. We substitute them in. Notice that in the denominator, what happens, we're going to get a minus, so we end up with the slope being minus 3 over 7. And then we use the point slope form. This is the point that we know, so it's y minus the y coordinate. That's y minus a minus 1 is y plus 1 is equal to minus 3 over 7 times the quantity x minus 4. If I multiply all the way through both sides by 7, I get this expression, which could be simplified into this. We also have a condition for lines being perpendicular. So if L1 and L2 are two distinct non-vertical lines that have slopes M1 and M2 respectively, then L1 is perpendicular to L2, written this way. We would read this: L1 is perpendicular to L2 if and only if M1 is equal to minus 1 over M2. The slopes are negative reciprocals of each other. If it turns out that one of the lines is vertical, the other line has to be horizontal to make it perpendicular, and a horizontal line would have 0 slope. And if a line is vertical, its slope is undefined because you have a 0 in the denominator. So find the equation of the line that passes through this point and is perpendicular to the line of example 5. And you might remember the line of example 5 had a slope of 2. You know what to do. Let's see how you did. Since the slope of the line in example 5 was 2, the required slope of the perpendicular line is minus 1/2. That's the negative reciprocal of 2. So it is going through this point, so it's y minus the y coordinate is equal to the slope minus 1/2 times x minus the x coordinate, and you can simplify it, and that's what you get. You can see that's what's going on over here in the picture with the red and blue lines. A straight line that is neither horizontal nor vertical cuts both the x and y axis in points. And when you cut the x-axis, y is going to be 0. When you cut the y-axis, x is going to be 0. So if you use the point slope form for this one with the y-intercept being 0b, you end up with y equals mx plus b. This is a very popular form of a line that is y is equal to mx plus b. It's called the slope-intercept form of the equation of a line. So an equation of a line that has slope m and intersects the y-axis at a point 0b is given by y equals mx plus b. Similarly, if we want to know what the slope is, if we solve an equation of a line that is neither horizontal nor vertical, actually it's actually really just neither vertical, then you can solve for y, and the coefficient on the x is the slope of the line. Here are 2 examples for you to do. Find an equation of a line that has slope 3 and y-intercept minus 4, but then the second one is a different concept, I suppose. Determine the slope and y-intercept of the line whose equation is given by this. You know what to do. Let's see how you did. So this is simply going to be in 8 is going to be y is equal to 3x minus 4. And here we have to solve for y. So we solve for y by subtracting 3x, then we divide by minus 4. So we get y is equal to 3 over 4x, and now it is minus 2. Remember, you're dividing 8 by the minus 4 as well. Life is a word problem, so we will be doing word problems. So please pause here and work these 2 problems. You know what to do. Let's see how you did. So in number 10, you find that the slope is 10, and you use the point that we have of 1 and 20. So y minus 20 is equal to 10 times x minus 1. and so we get y is equal to 10x plus 10. And so we'll substitute x equals 6, plug it in, and we'll get 70. Now we have to pay attention to what the problem told us, and so that's going to correspond, 70 is going to correspond to each unit is 10,000, so that is 700,000. In this one, it tells us that there's a constant rate of increase. That's the slope. So the slope is that, and we also know the intercept is that. So this is the equation of a line you should have gotten when we plug x rather to be 3. You get $65,000. The general form of an equation of a line looks like this. A, B, and C are constants, and x and y are variables raised to the first power. So this is called the general form of an equation of a line, and this is a line. And we state without proof that if we have an equation of a straight line, it's a linear equation, and every linear equation represents a straight line if we are to plot the points. So they two go hand in hand. One is an algebra representation, the other is a geometric representation. So you're to sketch the straight line represented by this equation. You know what to do. Let's see how you did. The easiest way to do a problem like this is to pick the intercept. So I pick y to be 0, I get x to be 4. And if I pick x to be 0, I get y to be minus 3. 2 points will determine a line, and that's all we need to do to plot that. To summarize then, we have equations of straight lines. A vertical line has an undefined slope, and that's in the form x is equal to a constant. A horizontal line has a slope of 0 and is of the form y equals b, a constant. The point slope form is y, the variable, minus the y coordinate is equal to m, the slope, times x, the variable, minus the x coordinate of the point. And if I have a line that has slope m and y-intercept 0b, the slope-intercept form is y is equal to mx plus b, and the general form is given by this, which we just discussed. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. God bless you all.